Okay, now dilations. We're going to talk about similar triangles, ways to prove triangles are similar, and then name those similar triangles again. And then we're going to talk about a little bit about that side splitter theorem and then the angle bisector theorem and how it relates. Right, that's something that wasn't on the quiz, but it will be on the test. The other thing that wasn't on the quiz that will be on the test is how scale factors related to ratio of perimeters and related to ratio of areas. So we'll touch on that again also. So again, we're going to kind of go over these things that were on the quiz today. You're going to finish your quiz review. And then we also have the test. Sorry, you're going to finish your quiz corrections. Then we also have the test review. And we'll work on that on Friday and Monday. Your test will be Tuesday. Okay. So we're going to take the test on the unit Tuesday. What's up, Daniel? Yeah, Tuesday. So if you didn't get your quiz back, I'll give it back to you today.
All right. What do we do on Monday?
On Monday, we'll continue the review. Okay. So tomorrow, I'll probably talk for most of the period today. We'll probably do examples together for most of the period today. Then tomorrow, you'll have time to do quiz corrections, start the test review if you haven't done so already. Monday, you'll have some time to finish the test review, but not the whole period because we're going to be doing some review again together. And then Tuesday's a test. All right. Any other questions? Again, let's practice things now and study before the test on Friday, right? So these examples that I'm giving you today, you can redo those later on, right? Can you do them again without looking at the answers? The test review has similar problems on it. A good review, go back and take the quiz again, right? Practice doing problems before you take the test. Make sure you know how to do them on your own without asking me questions, right? You can't ask me questions during the test. So can you do that stuff on your own before we take it? All right. What similarity shortcut did we use yesterday when finding those missing sides of triangles? Camille? Angle. Yeah, those all dealt with angle. So that was the first similarity shortcut. So we've already done some problems with that. There's another diagram that we've seen a lot that also proves triangles, or that we can also prove that two triangles are similar by angle. So if I've got these two triangles, P, Q, R, T, okay? You got that diagram right there? Those triangles are similar by angle. Where are the angles that I'm talking about? What angles? Rian? This is an R. Yeah, I'm fixing it right now. Come on, serious? All right, am I too sloppy? This is a P, Q, R, T, V. All right, we good? Okay. R, Q, T, and R, P, V are congruent because, yeah, they're corresponding angles, right? Parallel lines, corresponding angles congruent. Okay. What else? Aaron? Yeah, they both share angle R. That's it. I mean, that's all we need to know. We have more, but that's angle. In the little triangle, RQT, we've got two angles. In the big triangle, RPV, we've got two angles. The two triangles are similar by angle. Now, these angles are also congruent. Why are those congruent? Again, corresponding angles, right? Okay. So we have two triangles in here that are similar by angle. We can name the two similar triangles. If I call the little triangle RTQ, that is similar to what other triangle? Daniel? RVP, right. RVP. Okay. And from those similar triangles, we could set up a bunch of proportions. RT over RV. equals TQ over VP. You can do that by looking at the diagram and matching up right side to the little triangle, right side to the big triangle, bottom of the little triangle, bottom of the big triangle. Or you could set up the proportion by looking at how they're written. RT, first two letters. RV, first two letters. TQ, second two letters. VP, second two letters. Those form ratios. RT over RV equals TQ over VP. There's your proportion. You can cross multiply to find the missing side. What's the third ratio? Jira? Good. RQ over RP. So those are all the ratios you can set up from the similar triangles. Now, we discovered something different in class, where if we have a parallel line to another side, it divides the triangle proportionally. It was called the side splitter theorem. So instead of using the similar triangles, you could just do this over this equals this over this. So if I labeled this A and this B and this C and this D, A over B equals C over D. That was called the side splitter theorem. Parallel lines divide other lines, the ones they intersect, proportionally. And that dealt if I had like anything. I could draw two lines that look like this, and then draw parallel lines. Boom, 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 boom. We got all these parallel lines, right? So we can do this over this equals this over this. This whole length over this piece equals this whole length over this piece. And we made all those proportions. You remember that? Okay. That's the same kind of concept we're doing here. So that was the side splitter theorem. In that same unit, we did the angle bisector theorem. We'll talk about that now. So in that one, that's when we had a triangle with an angle bisector. Not a very good diagram, but those angles are congruent. Trust me, I mark them congruent, so they are. Okay? All right. And now we can do this. A, B, C, D. A over B equals C over D. Same thing. Or you can do A over C equals B over D. The one you can't do is when you crisscross. Remember, you can't do C over B equals A. You can't do that. Right? You remember this? All right. So that's something we haven't touched on in a few days. All right. That was not on the quiz. There'll be something on the test like that. There's stuff in the review like that. All right. So this one we derived, and we came up with this. We concluded this and discovered that when we from angle, and using those triangles. So it's all kind of related to that. All right, angle. We good with that one? What's the next one? Should we look at now? What's another way to prove triangle similar? Senor Sauce and side, side, side. So side, angle, side, or side, side, side. All right, you ready for side, side, side? Can I erase?
chat?
You know what I am happy about? Look at, after my rant from yesterday, Damon, you missed an awesome rant yesterday.
What was the rant about?
Well, you can watch it. Wait, did I tape my rant? I don't think I taped it. I think I started my recording after my rant. It was like, raise your hand if you actually studied for the test. And look, this is what happened. But actually, no, some people did. I'm sorry. I was like, did you actually go back and do the problems? Again, any of them, like just look at them. Did anybody even look at them? And it was like, everybody was just like, and I talk about taking, no, my main rant was like taking notes, remember? Yeah, so that was what I was gonna say. Look at, so my rant from yesterday worked. I just got a rant like every third day. And then people, oh yeah, that's right, we're supposed to take notes. You know, remind everybody. Is this side? Or did I mess up?
No.
Don't make mistakes. I thought I made a mistake once, but I was wrong.
He was wrong about. So you made a mistake.
No, this is side.
Yeah.
Well, like how? I don't get it. 6
Oh,
6
I
over
know.
20.
I remember.
4 times 4 is 6. 6 times 4. What? How do?
Turn it around.
Yeah, turn it around. Who said it's drawn the same way? What's the way to write the ratios? How do you know what 4 goes with in the other triangle? Jesus?
So like least to greatest, or like
Exactly, right. What's smallest and largest also, right?
4 is the smallest in LM and triangle LMC. So if you look at triangle QD, so we.
Very good, perfect. 4 is the smallest side here. 16 is the smallest side here. That's your ratio. The next smallest side here is 6. What's the next smallest side here? 24. What's the largest side here? 7. What's the largest side here? 28. Is 4 over 16, 6 over 24, and 7 over 28 the same thing? What do you mean pretty much? Or yes, they are. What if you reduce all those, you get what? You get 1 to 4. What do we call the 1 to 4? That's the, did you say X factor? Oh, scale factor. SF, scale factor, San Francisco. They're gonna win. Is San Francisco gonna win?
No.
This weekend? Who's San Francisco playing? They're playing the Rams. They beat the Rams to get into the playoffs. Are they gonna beat them again? No? Okay, SF doesn't stand for San Francisco, it stands for scale factor. Jesus.
Oh, wait, so when you lay out the fraction.
What? Sorry, Jesus, go ahead. Yeah, that's fine. That's fine. Yeah. So Jesus was saying he went this one to this one. That's fine. You just gotta, when you're finding missing sides, just make sure you set it up that way also.
I put you put the smaller numbers above the bigger ones, but I put the bigger ones.
He just did 16 over 4, 24 over 6. Okay? All right, now, the next thing we need to do is name the similar triangles. Now, you have to match it up so that the corresponding parts are written the same way, I guess. Is that what the word I was looking for? I was gonna say same order, sorry, same order, right? So triangle LMP is similar to what triangle? So you try first. Write down a triangle, see if you can match up the sides. We haven't even 10 tonight. I thought it was last week. No, we gotta win out to make the playoffs. We got 5 games left, we gotta win all 5. Last time we played Littleton, we lost 7-3. What do you think's gonna happen? Have you played Littleton? Yeah. Their 07s are good too. They got a good program. We got killed by their 09 team too. All right, what do you got? Who's got an answer for me? Let's check it out. Armana, go ahead. QWP. That means LM and QW. Oh, VVV, okay, VP, we got the mask on, we can't even hear each other, we got the mask on, okay, let's try, LM, QW, LM6, QW24, that was a ratio, MP, WV, MP4, WV16, boom, 4/16, LP, QV, LP7, QV, boom, all right, good, all right? So those are the similar triangles. So this was the other thing we talked about when we talked about similar triangles. This is the scale factor. What's the ratio of the perimeters? It's the same thing. It's 1:4. Don't believe me? What's the perimeter here? 17. What's the perimeter here? 68. This 24 and 16 is 40. 40 and 28, 68. 17/68. 1:4. It's the same thing. What's the ratio of the areas? 1 over, yeah, so 1 squared over 4 squared, you would square that. 1 squared over 4 squared is 1:16. The ratio of the areas is 1:16. So if the area of this triangle was 10, what would the area of this triangle be? If the area of this triangle is 10, what's the area of this triangle? Right, it would be 1/16 equals 10 over what? It'd be 160. You can cross multiply and solve, or you can be like 1 times 10 is 10, 16 times 10 is 160. Okay, if the area of this was 8, what's the area of this? 8 times 16, right? Okay, or 1 times 8 is 8, 16 times what? Where does 16 come from? You square the scale factor. If you take this and square it, it gives you the ratio of the areas. Okay, so whenever you're finding area, you need to find the ratio of the areas. Whenever you're finding a side length, you need to find the scale factor. Whenever you're finding perimeter, you also use the scale factor because the ratio of the perimeters is the same as the ratio of the scale factor. Okay, so whatever you're trying to find, that's the ratio you need to use. When we're finding areas, you have to use the ratio of the areas, which is what we did there. All right, now, I'm not going to do side angle side. If it was side angle side, I mean, we would just have like this. That might not be there, and that might not be there, and instead, we've got this, and then all that other junk is the same. Okay, so instead of giving you all 3 sides, I just give you 2 sides and the included angle. And then that side angle side. Sauce. It's sauce. I explained this to you already. I've precedent. Okay. What else we gotta do? Dilations? All right, so you're gonna need your Chromebooks. We're gonna find that piece of graph paper in your Chromebook. Yeah. I got.
Okay, so we're going right here, blank graph for dilations. Click on that. I don't have to, all my students last week took on my graph paper. I don't have an access. You instead of doing a sketch graph. You know, have done it. You're too lazy to get it out. Okay, so I'm going here, open this up. Oh, no, wrong one. Did I not click on the right one? Modules. Blank graph, oh, I clicked the wrong one. All right, so it's just a blank grid. Let's just do it like we had one on the quiz, right? If I'll make, remember you need a center of dilation, right? So we'll make it the origin. So we'll start at the origin. That's our center of dilation. And then we'll draw a triangle. Draw a triangle right here. It's not an assignment. It's just a file on there. It's called blank graph for dilations. Okay, now remember what I talked about. It's like the center of dilation is a light source. So this light source is hitting the triangle, and then its shadow is going to be over here. It's just like the projector, right? So this projector right here. You see the projector? There it is. So like that projector, right? It's got this light source in the back, okay? And then it's got the screen right here. It's like this. So that light source is hitting the screen, and then it's projecting onto the board. Right? That's a dilation. Now, if the light source, if the little screen was over here, and the light source was over here, right? Now it's going to hit it, and it's going to project over there. And if I move that thing closer, okay, that image is just close, right? Maybe close right here. Right? It's the light source, so the point of dilation. That's why there's a point. That's why we have this point right there. Okay? So we're going to start from there. Let's dilate this. And we'll dilate it by a scale factor of 2 to 1. What does that mean? So from this point to this point, we're going to double that distance. So let me take a different color. From here to here, I go up 1, 2, 3, 4, left 1, 2. Do it again. Up 1, 2, 3, 4, left 2. There's my new one. Geez, drawing with the smartest heart. Okay. So if this was point A, this is going to be A prime. Okay. Now we do it to point B. Up 2, left 2. Do it again. Up 2, left 2. We just doubled it. There is B. Here's C. Oh, no, that's B prime, right? That shows the transformation. Here's C. Up 2, left 1, 2, 3, 4, 5. Do it again. Up 2, 1, 2, left 1, 2, 3, 4. There's C prime. Here's Max prime. Okay. This was 2 units. Its dilation is 4. It's twice as big. This was 3 units. Its dilation is 6. It's twice as big. Okay? I'm going to put another one up and I'll try. Make it smaller? Not yet though. 2 to 2 would just be the same size. You could. You got to do fractions and we're not done. Okay. All right, let me undo. Clear all drawings. All right, so now let's do this. I'm going to put the I'll put the center of dilation here. I'm trying to draw with the mouse. Not that, oh, see, I just messed up. See? You messed me up. It's not easy. I'm trying. All right. Hopefully it'll fit. Okay, so let's do 3 to 1. So here's the center point. Dilate this triangle by a scale factor of 3 to 1. So now it's going to be 3 times as big. That's at 9, -7, the dilation point. 9, -7. Right in, 9, -7. Nine, -7. That's the light source. It's gonna hit the figure. Boom, it's gonna be over here. One time I did that, I hit this thing. And it wasn't connected out, and it shook the thing and it fell and almost killed me. That thing's heavy. Yeah. Like, see how big those hooks are? The hooks weren't that big, they're like smaller, and like shit. There, right out. Yeah, look how little those hooks are right now. Look how little those hooks are. See how it just bounce right out? This used to be a science room. You know, like a lab desk, that's why there's so many outlets. There's like a desk over there, desk over there, desk, there's like 6 desks. Well, there used to be. They took it all out. Look, that's how they have this thing. Turn the shower on. That's probably like, you know how they sanitize the eye things? I don't see how it's like sanitizing. Okay, is this mean we're done? All the time you can listen to me tell stories, that means we're done. You ready? Yeah, try things on your own, not wait for the teacher to do it. Yesterday. Just because you're wrong, what the teacher is doing, you understand it, you gotta be able to do it on your own. Without the help of the teacher. Who's the teacher? These guys are playing snowball fight outside. It's connected to the cafeteria. It's like, you can, yeah, you go right down here. You can go there right now. It's like the mask break area, right? Okay, ready? I'm ready. I'm ready. So up 1, 2, 3, 4, right? 1, 2, 3. Do it 2 more times for a total of 3. Once. Up 1, 2, 3, 4, right? 1, 2, 3, twice. Up 1, 2, 3, 4. Left 1, 2, 3, thrice. Once, twice, twice. 3 times. Okay, boom. Now, from here to here. I don't even have to move up or down. Left 1, 2, 3. Left 1, 2, 3. Left 1, 2, 3. There's that point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's 3. Oh my gosh, look at me drawing with the mouse. This is 3 times as big. Right? This was 4 units long. Now it's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This was 2, and now it's 1, 2, 3, 4. Wait, this was 2. Right, did I count wrong? 1, 2, 3, 4. Oh, I went too far. Should be right here. Oh, no. There. Okay? Dilation's good? All right, who wasn't here? Who did anybody not get their quiz back yesterday? Hold on. I don't know what I'm doing.